Welcome to this lesson on Boyle's law. This is one of the fundamental gas laws in chemistry that describes how gases behave under different conditions. Boyle's law specifically explains the relationship between pressure and volume of a gas. Understanding this law is essential for studying gas behavior and will help you solve many practical problems in chemistry and physics. Boyle's law is named after Robert Boyle, an Irish scientist who lived from 1627 to 1691. He was a pioneer in the field of chemistry and conducted numerous experiments with gases. Through his careful observations and experiments, Boyle discovered the mathematical relationship between the pressure and volume of gases when temperature is kept constant. His work laid the foundation for our modern understanding of gas behavior. Boyle's law states that when the temperature is constant, the pressure of a gas increases as its volume decreases, and vice versa. This means there is an inverse relationship between pressure and volume. If you compress a gas into a smaller volume, its pressure goes up. If you allow the gas to expand into a larger volume, its pressure goes down. This happens because the gas particles have less or more space to move around, affecting how often they collide with the container walls. The mathematical formula for Boyle's law can be written in two ways. The first form is P₁V₁ equals P₂V₂. Here, P1 and V1 represent the initial pressure and volume, while P2 and V2 represent the final pressure and volume. Another way to express this law is PV equals K, where K is a constant value. This means that for a given amount of gas at constant temperature, the product of pressure and volume always remains the same. Let us understand what each variable in the formula represents. P1 and P2 stand for the initial pressure and final pressure of the gas. Pressure can be measured in various units such as atmospheres, pascals, or millimeters of mercury. V1 and V2 represent the initial volume and final volume of the gas. Volume is commonly measured in liters, milliliters, or cubic meters. When using Boyle's law, make sure that the units for pressure are the same on both sides, and the units for volume are also the same. Let us solve a practical example to understand how to apply Boyle's law. Here is the problem. A gas occupies 500 milliliters at 1 atmosphere pressure. What will be the volume if the pressure is increased to 2 atmospheres at constant temperature? The given values are: initial volume V1 equals 500 milliliters, initial pressure P1 equals 1 atmosphere, final pressure P2 equals 2 atmospheres, and we need to find the final volume V2. Now let us solve this problem step by step. First, we apply the Boyle's law formula. P₁V₁ equals P₂V₂. Next, we substitute the given values into the formula. 1 atmosphere times 500 milliliters equals 2 atmospheres times V2. To solve for V2, we divide both sides by 2 atmospheres. This gives us V2 equals 500 milliliters divided by 2, which equals 250 milliliters. Therefore, the final volume is 250 milliliters. Let us summarize the key points about Boyle's law. First, pressure and volume are inversely proportional at constant temperature. This means when one increases, the other decreases. Second, use the formula P₁V₁ equals P₂V₂ to solve problems involving gas compression or expansion. Finally, remember that temperature must remain constant for Boyle's law to apply. If temperature changes, you will need to use other gas laws. Understanding Boyle's law is crucial for studying gas behavior and solving real-world problems.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.